This video is about Newton's first and second laws. Newton's first law is also called the law of inertia, and it says an object at rest stays at rest, and an object in motion stays in motion at a constant velocity until acted on by an unbalanced force. The more mass an object has, the more it resists acceleration, and so we say that mass resists acceleration. A non-zero net force is what's required to change the object's motion, that is to accelerate it. So we see an unbalanced force, we know that means a net force that's not zero. And so a net force causes acceleration. So to do physics, we want to get a little bit more specific and figure out by how much does the net force cause acceleration? What kind of effect does mass have on acceleration? How much of an effect? So to do this, we can do a science experiment. We need to do two experiments to show the relationship between the two different quantities. Let's start with the net force quantity here. So if we're going to be testing out the relationship between net force and acceleration, we're going to manipulate the net force we push on an object, increasing it and seeing how that affects the object's acceleration. We don't want the mass to really affect our acceleration, so we keep that as a controlled quantity. And what we find is as you increase the amount of net force on the x-axis here, the acceleration goes up at a steady rate. It's directly proportional. And so we say here, acceleration is proportional to the net force, directly proportional. On the other hand, if we wanted to find the relationship between mass and acceleration, we manipulate the mass of an object, we can make it heavier and heavier, and then see how that affects the acceleration, while we keep the same amount of net force applied to the object. As we do that, you notice that the acceleration gets less and less and less as we increase the mass. So as the mass goes up, the acceleration goes down. And the specific mathematical relationship for this is inversely proportional. So the acceleration is proportional to the inverse of the mass. Now, if we notice, acceleration is really proportional to two different quantities. We've got the net force over here and the inverse of the mass over here. And we can combine these two into one equation and change this to an equal sign. And this tells us that the acceleration of any object is equal to the amount of force applied to the object divided by the mass of the object. And this equation is known as Newton's second law. And it's an equation because we have come up with a unit for force called the Newton, and 1 Newton is equal to 1 kilogram times meter per second squared. And so when we define a Newton in this way, and we use units of mass in kilograms in the denominator, we have 1 Newton, which is 1 kilogram times meter per second squared, divided by a kilogram of mass. The kilograms will cancel out, and we're left with meters per second squared, which is a unit for acceleration. So this equation is foundational to understanding how things move and why they move the way they do. Anytime an object accelerates, it's going to be predicted by how much net force is acting on that object and the mass of that object. We often rearrange this equation this way. You might see this written in different places. The F net force is equal to mass times acceleration. All we've done is we've gotten rid of the fraction. We've multiplied by mass on both sides. So F equals ma is a pretty common expression. It's almost as common as E equals mc squared. F equals ma. That's another common physics equation, and it means the same thing. This one is just a little bit more conceptually accurate because the acceleration depends on these two quantities. So I prefer to use this equation, but this one is the same equation, just rearranged. And actually, there's a little trick that you can do. Anytime we have simple 3-variable equations like this, you can rearrange it into a triangle. And the reason why you do this is if you're trying to solve problems, it makes solving problems a little bit quicker because mathematically, you can cover up the variable that you want with your hand or with something, and then do the remaining math operation that's there. So if we wanted to find the net force, for example, if we cover it up with our hand, then what we do is mass times acceleration. If they're on the bottom together, we multiply them together. If we wanted to find the acceleration of the object, we cover up the acceleration and we do the net force divided by the mass. So F net over mass. And likewise, if you want to find the mass of an object given its acceleration and net force, you cover up the mass and you do net force over acceleration. So you can use this little triangle to make things a little bit quicker. Let's use it right now. In this example, it says an 850 kilogram car is pushed with a net force of 2250 newtons. How much does it accelerate? So if I'm looking for acceleration, I can cover up the A, and I have net force over mass. So acceleration equals net force over the mass. And my net force is 2,250 newtons. My mass is 850 kilograms. And so I put that into my calculator. We get 2.6 for our value there, the magnitude. And the unit is newtons divided by kilograms. Remember, a newton is a kilogram times meter per second squared. So the kilograms cancel out. So we have 2.6 meters per second squared. So remember, confusion is the sweat of learning.